Okay, guys. Okay, here we go. So today we are going to talk about 3 useful ways to write equations. This is the foundation of a lot of stuff we're going to cover this year. Since you guys are already working on solving equations, you've learned how to solve equations, you know that an equation has an equal sign, you know that you can do things with equations, and there are often variables in equations, right? Well, up to this point, all our equations that we've been writing, at least most of them, have had one variable in it. And if you'll notice, if you have one equation with one variable, you can always solve that equation. Always. Okay, does that make sense? X plus 2 equals 10. X has got to be 8, right? Right? X plus 2. That's great. Whoever said that. Thank you, Wyatt. Is that you? X plus 2 equals 10. X must equal 8, right? You can always solve an equation with one variable in it. If you have 2 variables, you cannot solve an equation with one. You cannot, and you have 2 variables and one equation, you cannot solve it. You could actually do a picture of all the possibilities. If x were 0, y would be this. If x were 1, y would be that. If x were 2, y would be that. Except if x were 100, y would be that. If x were negative 100, y would be this. Right? You can actually represent in a picture an equation with 2 variables. And it's going to be a graph. You guys all know what graphs are, right? It's going to be a straight line. And so what we're going to talk about today are 3 useful ways to write an equation, a straight line equation. We're only talking about straight lines right now. So.
That poster.
Right. So that poster up there on the wall has y equals x, which represents a straight line, and then has y equals x squared, which represents a parabola. And it can either be a happy face parabola or a sad face parabola. It can be frown. Right? And then y equals x cubed, it actually changes, the parabola changes halfway from a sad face to a happy face. Do you see that? So half of it's sad and half of it's happy. And then we've got y equals the square root of x, and that's just sort of a weird parabola going off to the right, sort of half of a parabola. So, but we're only going to be talking about straight lines, okay? These are all going to be straight lines, okay? And I'll even put that maybe in the title so that you always have that. Straight lines. I hope that can be seen. Straight lines, yes, you can see that. Okay, so the first one is called the slope intercept. Form. And that is represented by a special equation, which many of you have seen. Some of you know really well, some of you don't know at all. But it's probably the most famous equation in algebra. Almost. Yes. What is it, Nathan?
Y equals mx plus b.
Yes, he is right. It is y equals mx plus b. Very, very useful equation. It'll probably become most people's favorite equation for straight lines because you will find, I'm going to be teaching you probably within the next week amazing ways to graph this that you have never learned before, and you can graph something within literally 4 seconds. I could graph y equals 2x plus 10 4 seconds or less. Yep. And so it's amazing if you learn my shortcuts. It's going to be helpful. Now, why do they call... Yes, Sal, go ahead first.
The day I shadowed here, it's what you were teaching.
Was I teaching that? Okay, cool. So why would I call this slope intercept? Does anybody have any idea? Anybody know? Yes.
Because the slope is like...
Yeah, like a slope, it's going to be a straight line. It's not going to be like this because we're only talking about straight lines. But what's the slope of my arms?
Your head.
It's not, there's no slope, right? If you're going skiing, this would not be a very fun slope, right?
This.
Oh boy, let's go skiing, you know? This looks like a great slope, right? No, it has no slope. It's zero slope, right? But what about this? Oh, now that looks a little more fun, right? Or this, right?
Yeah.
Or this.
Right?
Or like, yeah, some of you like this, right? Okay. So listen. So look, slope intercept. The reason it is called this is it's actually really important to memorize this, because if you always remember this title, slope intercept, you will know what did they give you in y equals mx plus b. They always give you in this equation. They give you the slope right off the top. You know immediately what the slope is, and you know immediately what the y-intercept is. You know how a graph has two lines? It's a vertical line and a horizontal line. The vertical line is what axis? Let me know. The y-axis, right? So whenever a line comes and crosses that y-axis, that's called the intercept point, the y-intercept, right? A line intercepts the y-axis at a point, right? That point is given to you immediately in this equation. Very useful information. So an example of this would be this. Y is equal to 2x plus 4. And I know, with this, I know that my m is my slope. And my b is my y-intercept.
Is this for useful ways for equations also count that like y the one that you were doing in this chat? Like
Point slope? Is that what I did?
I think so.
Point slope? It's similar. You'll see. You'll see how they. Right. So this is all useful information. I'm not going to go into it quite yet in more detail than this. Slope intercept form gives you two things. The m right there, in other words, in this case, the 2 tells you how much of a slope it is, right? And slope, I'll get into that further. Slope, I'll just say it now. Slope is the same thing as rise over, you know? Run, exactly. And if it's just so usually you want it to be written as a fraction. So what would be the fraction of 2? 2
over 1.
2 over 1, right? So that would mean I'm rising 2, like on a graph. Look over here on this graph.
Rising 2.
If I've got my graph and it starts here, I would rise. Let's say, well, yeah.
It starts.
Yeah, they're right. It doesn't start there. Let's just say I'm not going to explain this, but right now. But let's say I'm starting here, and I rise 2, I go up 2, and I run 1, and I put a dot. I rise 2, run 1, put a dot. Rise 2, run 1, put a dot. I have a straight line. Isn't that cool? Right? I actually just graphed that just now. I graphed this equation just now. That fast. That's how fast it is. Right? Notice this one. What's the b again? B is what?
Oh, it's a y-intercept.
It's my y-intercept. Look. So it crosses. So my y-intercept is positive 4. So if this is my y-axis, I go from 0, 0, and I go up 4. 1, 2, 3, 4, and I put a dot. And from there, I can go rise 2, run 1, rise 2, run 1, rise 2, run 1, rise 2, run 1. Right? I can go as many times as I want. It's always going to be a straight line. And that line will represent all the possibilities, especially if I put a little arrow on the end of it to tell you that it goes on forever. That represents all the possibilities. Okay? Kala. Okay, so that's the first useful way of writing an equation. The second one is, I'm going to say point slope. Formula. Or form. Whatever. Here's the formula. It is y.
Is that slope or scope?
That's a slope. Sorry. That's an L. All right. So y minus y sub 1 is equal to m times x minus x sub 1. So write that down. This is the formula that most people think, oh my gosh, how am I going to ever learn this? Well, if you learn it, you will save yourself hours of time in the future. So it's worth memorizing. It's not that hard. Y minus y1 is equal to m times x minus x1. Why would you think they call it the point slope formula? Because they give you what?
A point.
They give you a point in this immediately, and they give you a
Formula.
slope in this immediately. So what would your slope be? What would you think?
Still M.
It's still going to be m. Mathematicians love m for slope because m reminds them of slope. Slope, right? Slope. So I think mountain. I say mountain, right? Maybe. I don't know. I guess. Oh, that's true. I hadn't thought of that. You've got like two little bumps, like two little mountains next to each other, right? Whatever. Okay. So m is your slope. Now, so m is your slope again. I'll just write that here. M equals slope, which is equal to what? Rise over run. Always remember that. You've got to memorize that. Okay? And then your point. This is your point. It's going to be x sub 1, comma, y sub 1. A comma doesn't look like a comma. That doesn't look like
What's
a comma.
sub 1 mean?
I can't get a comma. That's a comma. Okay? Okay, so now I'm going to write an example of this problem. Okay, like a real life example. So you could have something like this. Y minus 2 is equal to 1/3 times x minus 3. So that's like an example that you'd actually see possibly on a test or something. Y minus 2 is equal to 1/3 x minus 3. My point is going to be x1 comma y1. Notice there's a minus sign in the formula, right? So, and this says minus here. The minus is part of the formula, not part of the number. What is x1? x1 is this. x1 is the 3. So it's going to be this. Your point is this, 3. So it's going to be the opposite of whatever you see here. You see negative 3, it's going to be 3, comma, and then here's your y1. It's going to be opposite of what you see here. You see negative 2, it's going to be positive 2.
Oh.
If I lost you, don't worry, because we're going to go into this in detail in the future, right?
So it's
But I'm just, if you have this in your notes, it will be helpful because you can look at it later and you'll say, ah, I get it. Yes, Emma. Okay. But, so remember your x1 is over here, your y1's over here. It's not in the same order you'd expect. You'd think the x would be on the left and the y would be on the right, like it is in those things. But it's not in the point slope formula. It's the other way around. They should have written it the other way so it would be less likely to make mistakes, but they didn't. So there we go. That's the point slope formula. And the last one.
wait. So the point is the opposite of the number shown, like
Yeah.
2.
Yeah, like that would be, so like if I had, yeah, so this would be positive 3, positive 2. If I had written this as positive 3 here, this would be negative 3, positive 2. See what I mean? It's the opposite of what you see. Okay? So they give you a point, Kala. They give you a point and they give you a slope. So if I wanted to graph this, what's my point? 3, 2. I come over here, I go 3, 2, and I put my point, and then I'd use my slope, right? Which is rise 1, run 3. Rise 1, run 3. Boom. And I just graph from that line. Fast. So, Domenica and then Nathan. Yes, go ahead. Oh, is it cold in here?
I like it. No.
Okay,
It's hot.
Nathan?
Number 1.
Yes.
How did you get the 1 with under 2?
Oh,
Because you want your track
because you always want it to be, think of a slope as always a fraction. It's rise
So
over
if
run.
that was 2/3.
Then you just keep it as 2/3. Yeah, because it's not a fraction, because that is a fraction.
2/3/1.
2 isn't a fraction, so we turn it into a fraction by putting it over 1. Does that make sense? All right, so the third one, and I'm not going to go into much detail in this one, but it's called the standard form. You will learn this very well fairly soon. The standard form, and this formula is ax plus by equals c. And in a real life, the a is actually a number, the b is actually a real number, and the c is actually a real number. So an example would be 2x plus 3y is equal to 12. That's an example. So there are an infinite number of ways to write equations.
Oh, wait, wouldn't you just solve that the same way you solve a normal equation?
Wouldn't you solve it the same way? Well, but notice there are 2 variables. I wouldn't be able to solve this without knowing what one of the variables is. Does that make sense? It wouldn't work. I could say, okay, I'm going to figure out what x is, but wait, I don't know what y is. I can't find out what x is unless I know what y is. If I want to figure out what y is, I've got to know what x is, right? Yes, Sal.
Like eventually it'd just be x plus y equals 12, and any like x could be 0 and y could be 12, or x could be 1 and y could be 11.
Right, exactly. It could be like anything, right? And then you got negative numbers, right? So then, x could be negative something, and y would be positive something, and it would just go on forever, right? Infinite. Right. So this one, I'm going to talk about more later. There's not as many clear points that you can use in it. So there's a special way that we'll be solving those for graphing. But you will be using all 3 of these equations this year. So I think
X is most likely 3y.
say what?
X is probably 3y.
Could be. That's one option. But there are like an infinite number of possibilities, right?
That is one option.
Right, that is definitely one option. Okay, so the last thing I want to do before I end this lecture is I'm going to erase everything except slope-intercept. Okay? And we are going to graph using a very useful tool. It's called a T-chart. How many people know what a T-chart is?
Oh, you
Okay.
said teacher. I thought you said teacher.
Oh, a T-chart.
That's what I heard. Did
All right.
teacher?
A T-chart. All right, so this is very important to understand. You can graph any equation using a T-chart. I'm talking about straight line.
I don't think it's
All right, so that's like really important to understand. T-charts are your friend. So I am going to, as the year goes on, I'm going to be teaching you shortcuts to graphing things. T-charts are not the shortcut, but they work always. So if you ever are on a test, taking a test, and I ask you to graph something, and you're thinking, oh, I can't remember the shortcut. Well, then don't do the shortcut. Don't just guess. Do a T-chart and get it right. See what I mean? Why not? T-charts always work. All 3 of these useful ways of writing equations, you can graph with a T-chart. And all a T-chart is this. You draw a big T, well, actually a big small t, lowercase t. You put x on the left and y on the right. Okay? Always it's in alphabetical order, x first and then y. And you will be choosing values of x. You will not be choosing values of y. You will be choosing values of x. So what I usually do when I'm doing a straight line graph, I choose 0 as my first one, I choose 1 as my second number, and I choose 2 as my third number. I could choose a bigger number. You know, if I really wanted to, I could choose 2,453,263.241. And I would get an answer for y, but I would really rather not do all that work. You know what I mean? I would rather keep it simple. So these are pretty simple numbers. So I'm going to choose simple. So if I were going to do this, I would say, let's say we're going to use this equation. Y equals 2x plus 4. All right. So I want to know what y equals when x equals 0. So I'm going to substitute, instead of x, I'm going to substitute a 0 in place of the x in my equation. I'm going to see what happens. Y is equal to 2 times 0 plus 4. Who knows what 2 times 0 is?
0.
It's 0. So that crosses out, right? So I have y is equal to 4. You guys all agree with me? Yeah? So over here I put 4. That's my first point. My first point is 0, 4. Can you see that on there? Yeah.
Wait.
That makes sense?
No.
Who said no?
You get how that happens.
Okay. I'm saying I am going to try graphing this equation. And I'm trying to find points in the equation that are true. And you're trying to find things. So I'm going to choose my values of x. Doesn't matter. I could choose. There's an infinite number. Any number is okay for this, right? But I choose easy numbers because it's really easy to solve it when it's 0, when it's 1, and when it's 2. So I'm going to just do that. So I said, here's my equation. And instead of x here, I'm going to substitute it with a 0. I want to know what y equals. Liam, you see what I mean? I want to know what y equals when x is 0. So I'm going to try it. Y is equal to 2 times 0 plus 4. That crosses out. Y is equal to that. Okay? Y is 4. So I put it there.
I get it. Okay.
Right?
I get it. Yes.
All right. So now I'm going to try it for 1. I'm going to try it for 1. Y is equal to 2 times 1 plus 4. What is 2 times 1? 2. What's 4? Oh, 2 plus 4 is 6. So y is equal to 6, right? So I'm going to put a 6 right here. And that's my second point that I can graph. 1, 6. Now I'm going to, can I erase this?
No.
Okay. Now I'm going to do it as y, as when x is equal to 2. So y is equal to 2 times, instead of x, I'm going to put a 2 here, plus 4. So y is equal to 2 times 2 is 4, plus 4. So y is equal to 8. So over here, I am going to write an 8. And I am going to, there's my next point, 2, 8. All right? All you need is 3 points and you can graph a line.
Oh, and then
Right?
your slope would be 2 over 1.
Yeah, exactly. Good. You're right. Exactly. So if I were going to graph this, I'm going to come over here. I think this is seeable. What do we have again? We got, oh, go to 8. That's up though. That's okay. Okay, I just have to be sure you can see this. So I'm going to draw this line. This is my y-axis. Here's my x-axis. So this is my y-axis. This is my x-axis. And I'm going to graph these points. 0, 4. 0 means I don't go left or right at all. I just go up 4. 1, 2, 3, 4. The next one is 1, 6. I go to the right from 0, 0. I go to the right 1 and up 6. 1, 2, 3, 4, 5, 6. So I put a dot. And then 2, 8. From here I go over 2 and up 8. There's 6, 7, 8. Put a dot. And I have a straight line. Look at that. And I just graphed it. Does that make sense?
That's awesome.
T-charts always work. They are your friends. They are a little more work than the shortcuts. And they will take you about a minute. Shortcuts will take you about 4 to 10 seconds. But that's okay. If you forget it on a test, a minute's not that bad. Right? To get 100% on your test, a minute's worth it. Yes, Sakara. Question.
Where did we get the 2 from?
Which two? This one?
In the equations that.
In the equation?
Yeah.
I wrote it. I just decided this is an equation I want to play with today. Y equals 2x plus 4.
Okay.
And then that was just given. And then I said I want to graph it. So I said, okay, I'm going to try 0, 1, and 2 for my values of x
So
to see what y
you
is.
can just pick any number you want.
You can pick any number for x. You can pick, 20. You can pick 1,000. You can pick minus 2.5. The trouble is, they're harder to figure out what y is.
See, then you
I'd
have to
rather,
count at
and
the
then you'd have to
start and
graph it.
because
You've
then
got to. I'd have to. If I chose 100, right? Then suddenly my y, y is equal to 2 times 100. That's 200 plus 4, 204. I'd have to go very high on my graph, and I'd need a step ladder. I'd actually need a very large ladder, right? And I don't want to do
And
that.
another graph.
It's easier to keep it in a confined area, right?
Yeah, and you probably need another graph.
And a letter 3.
All right, so that's it for the class today.